Good morning, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. And today we will complete the leftover portion of differential equation which we have started in previous weekend's class. So in previous weekend we have done with the first order differential equation. We have just started higher order linear differential equation. So in this class we are going to cover the higher order linear differential equation and other solution aspects. So good morning, Amrita. How are you? So this is about me. I have been teaching in this domain, GATE and ESE domain, for more than 15 years. My subjects of interest are engineering, mathematics, analog circuits, and signals and systems. So these are the batches currently going on in our Gradeup platform: Vision 2022, Rank Up batch, and Gear Up batch. As per your requirement and your level, you can join the different batches. For any other information, you can take the screenshot and then analyze this information, and then you can contact at the number given below, which is 96500 52904. You can take the screenshot. Good morning, Jay. So these will be the faculties who will be dealing with the batches regarding GATE and ESE in ECE branch. Along with me, we have Rakesh sir, Sanjay sir, Hemen sir, Chandan Jha sir, and Chaitanya sir. All the faculties are experts in their domain. You can make use of their expertise and just cruise towards your aim. So these are our previous year achievers. You could be one among them, depending on you are doing some guided preparation. You are doing preparation in the right direction. So nothing is impossible. If you are really desperate regarding your goal or aim, definitely you can do it, you can achieve it. Amruta, I am fine, beta. Ankush, good morning. So now you can see the features of green card or Gradeup Super subscription. Again, I request you to take the screenshot. So green card has got various features, and our Gradeup Super subscription overall has got many features, many advantages for you. You can just take the screenshot and hence you can contact at the number given below. It will be always advisable to you that you should join Gradeup because we have very good team of faculties. We are committed to towards our goal. Your achievements should be our achievements. That's the thought we have in our mind. And yes, join early so that you can lead others. Gradeup Super subscription key features: structured live courses, full syllabus coverage, doubt resolution, and of course expert faculties. And you will be getting performance and report cards. So higher order linear differential equations. Higher order linear differential equations are of two types: one with constant coefficients, another with variable coefficients. So when we talk about constant coefficients or variable coefficients, then where are these coefficients present? ये coefficient कहाँ पर होते हैं? These coefficients are present as the coefficient of the derivative term. Coefficient of the derivative term. Okay. So when the coefficient of derivative term is constant, then such a differential equation will be called as LDE of higher order with constant coefficients. Whereas if the coefficients are variable, it will be called as linear differential equation with variable coefficients. But you have to remember one very important thought, that Here the variable involved as the coefficient of derivative term should be independent variable. So why this should be independent variable? Because देखो बच्चा, if this coefficient of derivative term is dependent variable, suppose if this would be dependent variable, then that differential equation will be non-linear. But we have linear differential equation. So if you are observing linear differential equation with variable coefficients, then number one, where are these variables present, or where are these constant coefficient present? These coefficients are the coefficients of derivative term. Okay, so when we talk about variable coefficient LDE, these variables must be independent variable. If these variable are dependent variable, then definitely your equation will not be linear, it will be non-linear. But we are talking about linear differential equation. So these coefficients, variable coefficient must be independent variable, they should not be dependent variable. Is that clear? Can I have your response? Chaliye. So this is the format of higher order linear differential equation with constant coefficients. So if you replace d by dx by d by dx by d, y is the dependent variable, x is the independent variable, coefficients are a0, a1, a2 up to an, they are all constants. So we can say that all these coefficients are constant, therefore this differential equation is linear differential equation with constant coefficients. These coefficients are the coefficients of derivative terms and they are all constants. और जब ये coefficient constants होंगे तो हमें कहना होगा कि this is a differential equation with constant coefficients. Yes? Okay. Now, if you write d by dx equal to d and y is taken out, then a naught d to the power n, a1 d to the power n minus 1, a2 d to the power n minus 2, and last term I am writing now an, y is taken out, and on the right hand side beta there should be capital X. Okay, generalized form. So right hand side is capital X. Now you may be thinking, what is this capital X? This capital X is the function of independent variable which is present on the right hand side. So this square bracket, this bracket is function of D. इस पूरे ब्रैकेट में जहां पर भी आपको दिखाई दे रहा है, आपको D या D की पावर्स दिखाई दे रही है. In this entire bracket, wherever you see, you can observe the powers of D. So I can say that this bracket is function of D. Function of D, and outside this bracket we have y equal to capital X. So now I can say that, let us say this is equation 1, and equation 1 is the most general form of an LDE of higher order with constant coefficients. Equation 1 is the most general form of an LDE, linear differential equation of higher order with constant coefficients. Is that clear? So this is the format of the constant coefficient linear differential equation. Okay, so we are interested in the solution of this type of differential equation. So solution of this equation 1 will be CS equal to CF plus PI. CS equal to CF plus PI. Now you may be knowing or you may not be knowing, it's not a big deal for you. Now you are going to learn. So CS is complete solution, CF is complementary function, and PI is particular integral. Okay, so when we talk about good morning Megha, how are you? So CS is complete solution. Generally this is all, not generally, it is always denoted by dependent variable in the equation. Suppose y is the dependent variable, so this CS will be denoted by y. If z is the dependent variable, CS will be denoted by z. Accordingly you can have the other notations also. Complementary function, this complementary function is that part of solution which contains arbitrary constants. So you can say that CF contains arbitrary constants such as C1, C2, C3, etc. and so on. How many arbitrary constants will be there in the solution? How many arbitrary constants will be there in the solution? It will depend on the order of the linear differential equation. What about pi? Pi is particular integral. Particular integral is a part of solution whose evaluation process depends on the function present on the right hand side. Now for your information, pi is having the format 1 upon f of d into capital X, where capital X is the function present on right hand side. Capital X is the function present on right hand side in the differential equation. What is this f of d? F of d is this bracket which contains function of d. अरे भैया, जब आपने d by dx की जगह पर d रखा था, y कॉमन लिया था, उसके बाद में ब्रैकेट में क्या बचा था? In that bracket there is a function of d. After replacing d by dx by d, you have taken d out of the bracket. Correct? Sorry, you have taken y out of the bracket. So whatever is remaining in the bracket are the terms containing d. So we can say that it will be function of d. So this is the format for pi. So देखो बच्चा, we have one method to find CF. We have one method to find CF. CF find करने का एक method है हमारे पास. In this method there are 4 cases. I discussed 4 cases. There are in fact 2 methods to find pi. There are 2 methods to find pi. Number 1, 6 cases. In the first method, you are going to study 6 cases. In the second method, when cases are not applicable, you are going for another method, that is variation of parameters. Method of variation of parameters. Is that clear? So complete solution will be CF plus PI. For finding CF, you have one method in which there are 4 cases. For finding PI, there are 2 methods. One method is containing 6 cases. Another method is variation of parameters. Generally, we apply a method of variation of parameters in the cases where none of the 6 cases are applicable. Okay, when the first method is not applicable, then we move towards variation of parameters. I'm not getting your responses. See here. This is the format of complete solution, CF plus PI. Yes, so this PI depends on right hand side. So if by chance right hand side variable is 0, in that case pi will be 0. So if you put pi equal to 0 in complete solution, then complete solution will be having only CF. Remember this. So when right hand side variable capital X is 0, you do not have to find pi because pi is 0 in that case. Complete solution will be only CF. Take your time. Take your time. Take the screenshot, please. I request all of you to hit the like button. Come on, fast. Next. So this is the method to find CF. What you have to do? You have to write the given differential equation in D form. After writing the given differential equation in D form, you have to write the auxiliary equation. The format for auxiliary equation is f of m equal to 0. See here. This is the format for auxiliary equation. Sir, how to write this auxiliary equation? Bacha, in f of d, d should be replaced by m. This d is replaced by m and equated to 0. Then we will be finding the roots of this auxiliary equation. After finding the roots of the auxiliary equation, we will be writing the CF according to the following cases. So case 1 when roots are real and distinct, case 2 when roots are real and equal, case 3 when roots are complex, and case 4 when roots are complex and repeated. So we already covered we already covered this portion in our previous class. So the portion which has to be started now is method to find pi. Okay. So method to find particular integral. We have got two methods. The first method will be having 6 cases, and the second method will be method of variation of parameters. So for information, the format for Anushri, good morning beta, how are you? See here. The format for finding pi is 1 upon f of d into capital X. It means pi depends, the method to evaluate pi depends on this right hand side function. Okay, so I'm just listing some. Ajay Kumar, good morning. I'm just listing some particular cases here. Case value of capital X, and there we have remark. Okay, so case 1 for finding pi is applicable when right hand side function is exponential function e raised to ax. Case 2 is applicable when right hand side function is capital X is sin ax or cos ax. Case 3 is applicable when right hand side function. Thank you Anushri. Mani, good morning beta, how are you Mani? Case number 3, when right hand side function is x to the power m, and this power m should be positive integer. This is very important remark. M must be positive integer, that is m should be 0, 1, 2, 3, 4 and so on. Case number 4, good, very good beta. Case number 4 is exponential into v. Now what is this v? This v can be from case 2 or case 3. So v can be, if it is from case 2, v can be sin x or cos x. I need your response. Or this v can be from case 3, that is x to the power m. Sorry. So if you closely observe, देखो बच्चा, if you closely observe exponential, see case 4 is exponential into v. Okay, अरे भाई exponential is case number 1. Exponential is case number 1, and v can be from case 2 or case 3. V can be from case 2 or case 3. So can I say that exponential into sine or cos means case 1 into case 2? Or can I say that exponential into x to the power m means case 1 into case 3? So now I can justify that case number 4 is the combination of case 1 with case 2 or case 1 with case 3. Can I have your response? Have you understood this? Case 4 is case 1 multiplied by case 2 or case 1 multiplied by case 3. Okay, sir. Case 5. Case 5 for finding pi. Case 5 for finding pi. Case 5 for finding pi is x into v, where v equal to sin ax or cos ax. It means case 5 is case 3. See, x means case 3 for m equal to 1. Case 3 for m equal to 1. And v is sin or cos. Sin or cos is case 2. So now we can say that case 5 is case 3 multiplied by case 2. Case 5 is case 3 for multiplied by case 2, and particularly case 3 for m equal to 1 here. Okay? Yes. No responses. Students are busy. Case 6. Case 6 is x to the power m into v, where v is coming from case 2. That's true. Sin ax or cos ax. Yes, Ajay, Gradeup is awesome. That's true. Gradeup has got some very good faculty teams, and I am also trying to match the level of my colleagues. So v equal to sin ax or cos ax, and this x to the power m, in this x to the power m, in this x to the power m, this m is a positive integer greater than 1. Because if you select m equal to 1, it will become case 5. So we have to keep a difference, say m equal to 2, 3, 4 and so on. So I wish that you should take the screenshot of this frame, and moreover I have a small information for you that case 1, 2, 3 are called as fundamental cases, and case 4, 5, 6 they are called as derived cases. देखो भाई, see here, these are fundamental cases and the other 3 are derived cases. Thank you, Ajay. Thanks a lot. It means a lot for me. So I just want all of you to have a screenshot, and then we'll move ahead. Done, sir. Thank you. We are moving ahead. Any issues, any doubts? Please let me know. I request all of you to hit the like button and stay tuned with me, because uh, maybe after 15 to 20 minutes you will realize, wow, this session is really great. You would have eliminated many of your doubts. So all of your doubts cannot be clarified immediately. You have to stay with me for longer duration. Okay? Next. So this is the table. You can take the screenshot of this. I already discussed this one. Next. This is case number 1. Now already we discussed that case number 1 is applied when right hand side function is exponential. When right hand side function of a differential equation is exponential, we are going to apply case number 1. देखो भाई, since pi equal to 1 upon f of d into capital X. F of d is e, okay, f of d is f of d. Capital X is e raised to ax. If it is e raised to ax, then we can say that it is case number 1. Case 1. See the exponentials index e to the power ax. So what is the coefficient of independent variable? Sir, coefficient of x is a. So what you have to do as a working rule in case 1? Sir, we have to replace d by a. It means wherever you have d in the denominator, that d has to be replaced by a. So it is quite obvious that if you replace d by a, now you are having a constant in the denominator, which is f of a. Arey bhai, so now you have to take care that this denominator constant should not be 0. This denominator constant should not be 0, because if denominator becomes 0, then it will become a non-existent term. So you have to provide a condition, provided this f of a should not be 0. But this is really not in our control. So if this denominator becomes 0, how to handle? What is the remedy? But in case if f of a becomes 0, then what you will get? Sir, pi will be 1 upon 0 e raised to ax. 1 upon 0 e raised to ax. So in that case you have to tell case 1 fails. Case 1 fails. So if case fails, what you have to do? Agar case fail hota hai to kya karna hoga? The step in which case is failed, point out that step. Yes sir, this is the step where case is failed. Now you have to move step by step in upward direction, in reverse direction. धीरे धीरे ऊपर की ओर चलना है. You have to move up, you have to move step by step upward, and you have to keep on observing in which step you are getting a function of d in the denominator. जिस स्टेप में केस फेल हुआ है उसके जस्ट ऊपर वाली वो स्टेप ढूंढेंगे जिसके डिनोमिनेटर में डी का फंक्शन हो. जिस स्टेप में केस फेल हुआ है उसके जस्ट ऊपर वाली वो स्टेप फाइंड करेंगे जिसमें डिनोमिनेटर में डी का फंक्शन हो. जिस स्टेप में केस फेल हुआ है उसके जस्ट ऊपर वाली वो स्टेप आइडेंटिफाई करेंगे जिसके डिनोमिनेटर में डी का फंक्शन हो. द स्टेप इन विच केस इज फेल्ड, you have to move upward step by step in such a manner, finding out the step in which you are having function of d in the denominator. So this is the step where case is failed. So here this is the upward step, but here we don't have function of d in the denominator. So again you have to move upward. Again you have, see, this is the step where case is failed. Now you have to move in upward direction. Now here there is no function of d in the denominator. No sir, this is not the step required. Again you have to move upward. Yes, this is the step where you have function of d in the denominator. Yes sir, yes sir, yes sir. So in this step what you have to do? In this step you have to select this step. This is your pi equal to, bacha, this 1 upon f of d is operator. This 1 upon f of d is called as operator. इस 1 upon f of d को क्या कहते हैं? Operator. So this 1 upon f of d is operator. Outside the operator you have to multiply by independent variable. यहाँ पर, here you have to multiply by independent variable. This place you have to apply independent variable. So independent variable in the process is x, and now you have to take the derivative of f of d, that is f dash d, an exponential term as it is. So two things you have to do as the remedy when case fails. When case fails, you have to find this step where you have function of d in the denominator. Then outside the operator you have to multiply by independent variable. Here the independent variable is x, and simultaneously you have to take the derivative of the denominator, that is f dash d. And now again you have to replace d by a. Again replace d by a. So what we will get now? Pi will be x 1 upon f dash d now became f dash a. So again this denominator became a constant, so you have to provide a condition that this f dash a should not be 0. But in case if this f dash a becomes 0, again you have to move to this step, multiply by x and take the derivative of the denominator. Okay. If this denominator becomes 0, then case 1 fails again. If case fails again, you have to move upward, find this step where you have function of d in the denominator, multiply by independent variable x, take the derivative of the denominator, again replace d by a. The process should be continued. This process will be continued until the case gets solved. Sir, when we will assume that the case is solved? When your denominator is free from d, it is containing a non-zero constant, you can say that case is solved. When the denominator contains non-zero constant, then you can say that case is solved. If d term is present in the denominator, case is not solved. If 0 is present in the denominator, case is not solved, case gets failed. So this is how you have to approach for case 1. Is that clear? Please take the screenshot of this if you wish. I request all of you to hit the like button. Now see this. Now whenever you have sin h theta or cos h theta on the right hand side, that is sin h or cos h function on the right hand side, what you can do? You can convert this sin h theta or cos h theta into exponential term. Varsha Agrawal is saying, sir, voice stop ho gaya hai. Okay, so I request others to comment by tagging Varsha that she can refresh her page. So this is sin h theta. Sin h theta can be converted into exponential by this formula. Cos h theta can be converted into exponential by this formula. Okay, now see here. So 2 cos hx, 2 e raised to x plus e raised to minus x upon 2. So easily I can say that 2 gets cancelled, and on the right hand side I am having 2 exponential terms. So pi is pi is 1 upon f of d into capital X. Now this f of d is function of d. See here, write this given differential equation in d form. So d square minus 3d plus 2y is taken out, and now on the right hand side we have e raised to x plus e raised to minus x. Yes sir. So d square minus 3d plus 2, this is function of d. Capital X is the function present on right hand side. Now what we can do, we can separate this into 2 parts. हम इसे 2 parts में distribute कर लेते हैं. pi 1 upon d square minus 3d plus 2 e raised to x plus again 1 upon d square minus 3d plus 2 e raised to minus x. So whenever you have exponential term, बच्चा, this is case 1. कौन सा case है? Case 1. So case 1, e raised to ax, a equal to 1. This is also case 1, e raised to ax, a equal to minus 1. Now what is the working rule to solve case number 1? Sir, working rule to solve case number 1 is you have to replace d by a. So if d is replaced by 1, 1 plus 2, 3, 3 minus 3, we are getting a 0 in the denominator. If 0 in the denominator means case 1 fails. See the second part. Replace d by minus 1. Replace d by minus 1. Minus 1 square is 1. 1 plus 2, 3. Minus 3 into minus 1 will be plus 3. It will be 1 by 6. So in the second part, case gets solved. But in the first part, case gets failed. So what you have to do now? Sir, we have to apply a remedy step. You have to select this part. In the first part, you have to apply the remedy step. You have to multiply by independent variable x here, outside this. So x Now simultaneously you have to take the derivative of the denominator. Derivative of denominator is twice d minus 3. कोई response नहीं है. No response at all. I request all of you to hit the like button. Stay tuned with me till the end of the session. You are going to get 1 or 2 marks in your upcoming exam from this session. Twice d minus 3 e raised to x. Second part is already solved. Now straight away you can replace this d by a. In the first part a is 1. Replace d by 1. Replace d by 1. So once you replace d by 1, 2 into 1 minus 3 is minus 1. So you are getting minus x e raised to x. Plus e raised to minus x upon 6. Actually, the students are confused while solving this type of questions when they deal with the different cases. So this is the PI. I hope you can find CF. I hope you can find the complete solution. So I have just determined the PI, the particular integral for this question, requesting all of you to find the CF and hence write the complete solution. Okay. Urmit Parmar. Great. Super. Urmit, Amruta, Venkat. I will be teaching how to solve the cases in this class. Unless and until we have the process to solve these differential equations, the normal questions, what we can do with the initial condition, that will be difficult. So we will be putting our concentration on methodology in this session, and it will be not of big deal. It will be not of what I say, much difficult set of questions if some initial conditions are also given. So this part is really important and little bit difficult, so that you have to understand. Now case number 2. Case number 2. Pi is 1 upon f of d into capital X. F of d into capital X. Capital X is sine or cos? Of course. So sine or cos means case number 2. In case 2, what is the working rule? See here. In this case number 2, you can just note down one point. आप एक point लिखिए सब लोग. Please note down one point in your notebook. Express f of d in denominator as a quadratic function. Express f of d in denominator as a quadratic function. Express f of d in denominator as a quadratic function. Quadratic function means as a function of d square. As a function of d square. So you have to express f of d as a function of d square. Sir, कैसे करेंगे? How we are going to find this? That I will be going to teach you in live question. That how to get this function of d square in the denominator. Okay. So just you have to note one step. Express f of d in denominator as a function of d square. Okay, sir. So now what you have to do? Once you express this function as a function of d square, what do you have to do? Sir, we have to replace d square by minus a square. Take care, you do not have to replace d. You have to replace only d square. You have to replace only d square. You cannot touch d. D should remain as it is. Shabash Venkat. D square should be replaced by minus a square, and moreover, first you have to square and then multiply by minus sign. So first you have to find a, square it, and then multiply by minus sign. So what you are going to get now? Pi will be 1 upon phi of minus a square sine ax or cos ax. Now, bachas, this denominator is a constant. This denominator is a constant, and this constant can be 0. So you have to provide a condition that this denominator phi of minus a square should not be 0. Should not be 0. So pi. And if this becomes 0, if this denominator becomes 0, if phi of minus a square becomes 0, in that case pi will be 1 upon 0 sine or cos. So now I have to make a comment, case 2 fails. And when case is failed, you have to go to the remedy step. Remedy step means that step where you have function of d in the denominator. So this is not the remedy step because you don't have function of d in the denominator here. So और पीछे जाइए, पीछे देखो पीछे. So here 1 upon phi of d square sin x or cos x. This is the remedy step. Here you have to multiply by x outside the operator. X is the independent variable here, and simultaneously you have to take the derivative of the denominator. So x 1 upon phi of d square will become phi dash d square. Bacha, this derivative is just symbolic. Don't take the complete derivative by applying chain rule or anything else. This phi dash is just the symbolic notation. Take care. In live question, we will be doing the actual part. So again replace d square by minus a square. And the process should be continued. Till we get a function of, till we get a non-zero constant in the denominator. Okay? Yes, sir. Please take the screenshot. Jaldi se screenshot le lijiye. Hit the like button also. Stay tuned. Case 2 application is really best among all the 6 cases. Little bit complicated. The most important part of learning regarding case 2 is still pending. Stay tuned with me. Now see this question, bacha. Stay tuned for the next 10-15 minutes. You will be realizing that yes, this teacher has given us something new. First of all, we'll be writing this equation in D form. D square plus 2d plus 2 into y equal to sine 2x. CF you find by yourself. PI I am doing for you. PI is 1 upon f of d into right hand side function sine 2x. देखो भाई, sin ax means case 2. Sin ax, the value of a is 2. Value of a square will be 4. Minus a square will be minus 4. And what you have to do? Replace d square by minus a square. Replace d square by minus a square. So now we are going to execute the working rule. Sir, you said that you have to express the denominator as a function of d square. Arey bacha, this function is already having a d square term in the denominator. This is already a quadratic function. No need to do anything else. So 1 upon this d square should be replaced by minus a square, that is minus 4. Sin 2x remain as it is. See here, d remains as it is. We replace d square by minus 4. Hello? No need to disturb d. D square is replaced by minus a square, that is minus 4. D remains as it is. So 2d minus 2. 2 is common. So d minus 1. Sin 2x. Now see here, very important step. देखो भाई, 1 by 2 out, 1 upon d minus 1. sine 2x. See here, our case is not get solved, and we are not having function of d in the denominator. So what to do? You have to rationalize the denominator. What is the meaning of rationalizing? Just change this middle sign and multiply by the factor in numerator and denominator. So d plus 1 should be multiplied and divided. This is called as rationalizing. So d plus 1 will be there in the numerator, and d square minus 1, a minus b, a plus b, d square minus 1 will be there in the denominator. Now what is the working rule for case 2? अरे भाई केस 2 का वर्किंग रूल क्या है? द वर्किंग रूल फॉर केस 2 इज रिप्लेस डी स्क्वायर बाय माइनस ए स्क्वायर. This d square should be replaced by minus 4. So minus 4 minus 1 minus 5. हाँ, एक बात का ध्यान रखना है, जब तक डिनोमिनेटर एग्जिस्ट ना करे तब तक न्यूमरेटर सॉल्व ना करे. अनलेस एंड अनटिल डिनोमिनेटर एग्जिस्ट, डू नॉट डिस्टर्ब द न्यूमरेटर. Now I need your concentration. So minus 1 by 10 out. अरे भाई d stands for differentiation, derivative of sine 2x, 2 cos 2x, and 1 into sine 2x will be sine 2x. So pi is minus 1 by 10, 2 cos 2x plus sine 2x. This is your pi. So requesting all of you to write the complete solution by finding CF. Understood everybody? So this is one of the problem regarding case 2. Bacha, there is one more question for you regarding case 2. D square plus 4 into y equal to cos 2x. Now pi 1 upon d square plus 4 cos 2x. This is case 2. Value of a is 2. A square will be 4. And now I am multiplying by minus sign. Minus a square is minus 4. What is the working rule to find? What is the working rule to find pi for case 2? Sir, you have to replace d square by minus a square. D square की जगह पर minus a square रखना है. D square is minus 4. Minus 4 plus 4 is 0. केस 2 फेल्स. क्या करें? सेंटर फ्रेश लाना पड़ेगा. केस 2 फेल्स, केस 2 फेल्स, केस 2 फेल्स, केस 2 फेल्स. So you have to go to the remedy step, and this outside the operator you have to multiply by independent variable, and at the same time you have to take the derivative of the denominator. So pi will be x by 2 out. D stands for derivative. Hello, D stands for derivative. Then 1 upon D denotes integration. 1 upon D denotes integration. So integration of cos 2x. See, which function is written on the right hand side of 1 by D? X is not written. So do not integrate x. You have to integrate only cos 2x. So x by 2, integration of cos 2x is sin 2x by 2. So x sin 2x by 2, that is 4. And no need to add any arbitrary constant also after this integration. Reason is same, because all the arbitrary constants will be there as a part of CF, not in the pi. In pi you will not be having arbitrary constants. Okay, next. Case 3. Case 3 for finding pi. 1 upon f of d. Right hand side function is x raised to m. and m must be positive integer. If m is a fraction or negative value, if m is a fraction or negative integer or negative fraction, then we cannot apply case 3. It will be not any of the cases. It will not be any of the cases. So I am dictating one point. You have to. I request all of you to hit the like button. I request all of you to hit the like button. Now, you have to write one step. You have to write one step. एक point बोलता हूँ, important point है. Please note down. I'm dictating one point. Take out the lowest degree term common from f of d in denominator. Take out the lowest degree term common from f of d in denominator. Take out the lowest degree term common from f of d in denominator, so that the remaining function will be of the form 1 plus phi of d. रिस्पॉन्स ही नहीं आता बच्चों का. Take out the lowest degree term common from f of d in denominator, so that the remaining function will be of the form 1 plus phi of d. So 1 by k. This square bracket is having power 1. You can take this bracket to the numerator. Take this bracket to the numerator with a negative index of unity. ऊपर लाएंगे तो power -1 हो जाएगा. And now you can expand this bracket, which is having power -1, by binomial theorem. 1 plus a to the power -1 will be 1 minus a plus a square minus a cube plus and so on. Alternate plus minus signs. In another formula, if it is 1 minus a to the power -1, thanks a lot all of you, this will be 1 plus a square plus a cube and so on. Yes sir. All of you stay tuned. For next 10 minutes, you will be definitely getting one very important and beautiful concept regarding case number 3. All your confusions will be eliminated with the problems involving case 3. Okay. Now what to do? Up to which term you have to expand and all, you have to see, you will be seeing in the live question. See here, in d form, this is d square minus 1 into y equal to x square plus 1. Are you enjoying? Pi will be 1 upon d square minus 1 x square plus 1. Okay, so x to the power m is 2, positive integer. 1 can be written as x to the power 0. 0 is also a positive integer. So this is case number 3. In case number 3, what you have to do, you have to take out the lowest degree term common. So here lowest degree term is 1 or -1. So I am taking -1 common. So this will become 1 minus d square. Okay sir. So Venkat, beta, you have the patience to hear, and that's why you are finding these sessions good. Students are having patience. Those students having the patience to learn, they will feel the faculties are good. So in fact, many faculties in the domain are very good, superb teachers. But Student have the patience to learn. So since you are having the patience, you are learning it. Thank you, beta. What is the biggest ornament in a student's behavior? You know, politeness and patience. This will be helping you always in your career. So this 1 minus d square is brought to the numerator with a negative index of unity. Okay, sir. So see here, 1 minus a to the power minus 1. What is the formula? What is the formula? 1 plus a square plus and so on. This will go up to railway station. Infinite series है भाई, चलता चला जाएगा. This will go up to infinite. But we have to restrict ourselves up to the degree of this function. So what is the degree of this function? Degree of this function is 2. So we will be expanding this up to a square. Now what is a here? 1 minus a. 1 minus a. A equal to d square. So 1 plus a square. Bracket close. So 2 times you have to consider the terms. First time you have to consider the terms by for expanding this formula. Up to which degree you have to expand? We have to expand up to degree m. Now again you can see here d square stands for double derivative. Double derivative of this term will exist. D raised to 4. D raised to 4 stands for fourth order derivative. Fourth order derivative of this term does not exist. It will be 0. So cancel it. Neglect it. Are you following? भाई cancel क्यों कर रहे हैं? Fourth order derivative. This is fourth order derivative of this function. For x square, first order derivative is 2x. Second order derivative is only 2. Third order will be 0. Fourth order will be 0. So we already neglected it. Even if you consider it, it will be 0. So 1 into x square plus 1. D square means double derivative. Double derivative of this term will be 2. So requesting all of you not to leave for only PI. You have to just find out CF as well as complete solution. Find CF and then combine this PI with the CF to get the complete solution. Okay? Yes, sir. Requesting all of you to hit the like button if you have not done so. Next. Please have a look over this. Give me 1 minute. Give me 1 minute. I'll be right back. Urmit Parmar, you can see my previous class, last Saturday's class, to know how to find CF. What you can do? You can write the auxiliary equation. See, in this d square minus 1, put d equal to m. Roots plus minus 1. So one root is plus 1, another root is minus 1. So roots are real and different. So there are 4 cases. So for real and different roots, first case for finding CF. c1 e to the power 1x, c2 e to the power minus x. So complete solution will be cf plus pi. Next, case 4. Case 4 is exponential into v, where v is sin x or cos x or x to the power m. So pi will be 1 upon f of d into capital X. 1 upon f of d capital X is exponential into v. Now see here, this is exponential into v, that this is case 4. What is the working rule? What is the working rule? Elementary step to solve case 4. See here, all my dear students, see here. This 1 upon f of d is operator. क्या कहते हैं इसे? Operator. This 1 upon f of d is operator. So you have to take out this exponential term of this operator. Operator से बाहर निकालना exponential term को. You have to take out exponential term out of the operator, and this v will remain as it is. v अपनी जगह पर रहेगा. आलोक सिंह, गुड मॉर्निंग. लेट हो गए बच्चा. So you have to take out this exponential term out of the operator. Alok, since July I joined Gradeup to serve a different set of students who cannot reach me in physical classes. Ananya, good morning beta, how are you? Late हो गई बच्ची. Exponential term should be taken out of the operator side. Exponential is out, v will remain as it is. Exponential term को operator से बाहर निकालेंगे. v के साथ कुछ ना करें, v अपनी जगह पर रहेगा. v will remain as it is. At the same time, this d should be replaced by d plus a. d should be replaced by d plus a. So wherever you have d will be replaced by d plus a. And see, once again, फिर से बोल देता हूं एक बार, आप ध्यान से देखिए. See it once more. All my students, see here. How to solve case number 4? Exponential into v. Exponential term should be taken out of the operator. Exponential term को operator से बाहर ले लेंगे. Super. Yes. Exponential term is out of the operator. V will remain as it is, and in f of d will be replaced by d plus a. Okay. So this is how okay Ananya. Now see, this is f of d plus a into v. What is this v? Sine or cos. If it is sine or cos, you have to apply case 2. If it is x to the power m, it is case 3. So if you apply a single step, I am nothing, I am just a person who transforms the concepts. That's it. I am nothing. There are some gurus. Much. I am nothing in front of them. Once you replaced exponential term out of the operator, the case 4 will get converted to case 2 or case 3. Take the screenshot of this. I request all of you to stay tuned with me till I complete the question, at least till I complete the question regarding case 4. Tanuj, we will plan for that. I request all of you to hit the like button and stay tuned with me till I solve at least one question regarding case 4 to get a command over case 4. Okay? Yes, sir. So case number 4. देखो भाई, first of all we have to write the given differential equation in D form. D by dx should be replaced by D. Y is taken common. चलो भैया बाहर निकलो, कम आउटसाइड. यस, e raised to minus x sin 2x. So now pi. Love your comment, Venkat. यस उर्मित परमार, एग्जाम्पल उसी का ले रहे हैं. 1/f of d into capital X f of d square minus 2d plus 2 e raised to minus x sin 2x. चलिए देखो भाई, एक्सपोनेंशियल इंटू v where v is sin or cos. Alok, which center beta? In which center you studied from me? Which place? Case 4. So exponential term should be taken out of the operator. Here a is minus 1. Sin 2x remains as it is. Wherever you have d, d will be replaced by d plus a. Please concentrate. Exponential is out of the operator. Sin 2x remains as it is. D will be replaced by d plus a. Here a is minus 1, that is exponential's index. So wherever you have d will be replaced by d minus 1. So d square, that is d minus 1 square. 2d means 2d minus 1 plus 2. Okay. Now I am going to simplify it. D square minus 2d and minus 2d. अच्छा, minus 4d and plus 1 plus 2 plus 1 plus 2 plus 3, again plus 2 will be plus 5. All of you understood till this step? यहां तक बात समझ में आई? All of you understood till this step? वेंकट भाई, कॉम्प्लेक्स वेरिएबल पार्ट 2 will be tomorrow 9 AM. लंबा क्लास रहेगा वो. So d square will be replaced by, उर्मित क्या हो गया बेटा? Replace d square by minus a square. D square is replaced by minus 4. This is case 2. D square is replaced by minus a square. Chandrakala Khatri, this is not for class 12th. D square is replaced by minus 4 plus 5 plus 1. Minus 4 plus 5 is plus 1. Now you can rationalize the denominator. So A minus sign is taken out, so this became 4d minus 1. Rationalize the denominator, 4d plus 1 upon 4d plus 1, and you have sine 2x. कोई बात नहीं बेटा, करेक्ट कर लीजिए. 4d minus 1, 4d plus 1 will be 16d square minus 1 sine 2x. Now you have to replace d square by minus a square. So minus a square is minus 4. 16 into minus 4 will be minus 64. Minus 64 minus 1 will be minus 65. So minus minus cancel, 1 by 65 e raised to minus x. Four times derivative 4d plus 1 ना, बोलते ही नहीं है. 4d plus 1. Requesting all of you to hit the like button if you have not done so. Your liking the session is the source of energy for me. Four derivative of sine 2x is 2 cos 2x. And 1 into sine 2x will be sine 2x. Check it once. 8 cos 2x plus sine 2x. Can I have your response? All of you understood how to find pi? Have you all understood how to apply case number 4? Please take the screenshot. Successive differentiation, beta, this is not the class for class 12. This is class for GATE and ESE aspirants. Please go and search some of the class on our different channel where you will be having successive differentiation for class 12 preparation. I think you are from JEE section. Okay. Now case 5. In case 5, this V can be sin x or cos x. So case 5 can be considered as the product of case 1 with case 2. Case 1 with case 2. And yes, this V can be sin or cos. M is a positive integer equal to 1. Now, Pi equal to 1 upon f of d into capital X. Capital X is x into V. Okay, sir. What to do now? अब क्या करें? क्या करें? क्या करें? क्या करें? So for case 5, there is a direct formula. X is out. 1 upon f of d into V minus second term derivative of f of d, f dash d. In engineering, in gate domain we do not need successive differentiation. I think you are a first year engineering student. You are a first year engineering student and you are stuck in somewhere in Leibniz rule, Leibniz product rule. Correct? So this is the formula for case 5. So once you applied case number 5, the case 5 gets reduced to case 2. So V is sine or cos. Case number 2. Next. See here. d2y by dx square plus 4y equal to x sin x plus 2 raised to x. Okay, sir. So 2 raised to x is, see here, 2 raised to x can be written as e to the power log 2 raised to x. So e raised to log x log 2, e to the power log 2x. बादलों के दरमियां कुछ ऐसी साजिश हुई, मेरा घर मिट्टी का था, मेरे ही घर बारिश हुई. So write this equation in D form. D square plus 4 into y equal to x sin x plus 2 raised to x. And this 2 raised to x can be written as e to 2 raised to x को क्या लिख सकते हैं? 2 raised to x can be written as e raised to log 2x. Now see, we will be finding out the pi for this. Okay, इसका pi निकाल लेते हैं. चलिए, 1 upon f of d and right hand side function. On right hand side you have two terms, so I am separating these terms now. So this 2 raised to x can be written as e raised to log 2x, and once it is written as e raised to log 2x, which case is applicable? Now see here, Harry, आ जाओ. X into sin x, x into sin x, this is case 5. E raised to ax, this is case number 1. Okay, sir. In case number 5, what you have to do? In case number 5, x is out, 1 upon f of d into v minus f dash d in the numerator, and then square of f of d in the denominator, sin x. And this second part is case 1. In case 1 you have to replace d by a. जहां पर d है वहां पर a रखना है. a is log 2. So this is 1 upon log 2 whole square plus 4, and e raised to log 2x. e raised to log 2x can again be written as 2 raised to x. काम हो गया, वापस से ओरिजिनल फॉर्मेट पर आ गए. Again we have written the original format after completion of our job. X sin x, this is case 2. In case 2 you have to replace d square by minus a square. Minus a square is minus 1, so minus 1 plus 4 will be 3. Need your response. 2d sin x, d square is replaced by, see this is case 2, d square is replaced by minus 1. Minus 1 plus 4 is 3. 3 square is 9. This second term remains as it is, 2 raised to x upon log 2 square plus 4. Now x sin x by 3 एक मिनट रुक सकते हैं सर, केवल रह सकते हैं। x sin x by 3 minus 2 by 9, derivative of sin x is cos x, so minus 2 by 9 cos x, and this term 2 raised to x upon log 2 square plus 4, and this is your pi. This is the pi. Okay, this is the pi. So you can write the complete solution by writing the CF also. So CF plus pi will be the complete solution. Yes sir, can I have your response? Can I get your likes on this session? So till now we have covered method to find pi. In the first method there are 6 cases. Out of the first 6 cases we have covered 5 cases. We have covered 5 cases till now. Okay, case 6 is little bit lengthy, that I will try to cover somewhere else if possible. And let me tell you another method to find pi first, that is method of variation of parameters. Case 6 is pending, will remain pending till I will cover this case 6. It's a lengthy process. So we will spend some more time. It will take some 40 minutes to explain case 6 as well as the solving the questions again required. So 1 hour separately required for case 6. In that time we will be covering method of variation of parameters, which is useful for you. So method of separation of variables. So generally this method can be applied for any value of capital X on the right hand side of the differential equation. We can apply method of variation of parameter to find pi, for finding pi for any value of capital X on the right hand side, but ultimately we will be applying this method only in the cases where none of the 6 cases are applicable. So first we will try whether any of the cases are applicable. If cases are applicable, we will be applying the cases. If cases are not applicable, we will be going for method of variation of parameters. So method of variation of parameters. First step is you have to find CF. Second step is compare CF with CF equal to C1y1 plus C2y2. You have to compare your CF with this format, CF equal to C1y1 plus C2y2. You have to find y1 and y2. Then you have to find y1 dash and y2 dash, that is the derivatives. Common term format will be y1 y2 dash minus y2 y1 dash. You have to find u and v. Format for u and v is this one, these two integrations. Take the screenshot of this. Finally, you have to write pi as pi equal to uy1 plus vy2. And then you have to write complete solution as CS equal to CF plus pi. Now see here. See the right hand side. In this right hand side function, the right hand side function does not matches with any of the cases. So we are going to apply variation of parameters. So first of all, we'll be finding the CF. Write the auxiliary equation. So m equal to 0 plus minus I. M equal to 0 plus minus I. So roots are complex. Alpha is 0, beta is 1. So CF will be e raised to 0x C1 cos beta x possible nahi hai. This is the last question for today's session. So C1 cos x plus C2 sin x. This is CF. After getting the CF, you can compare CF with C1 y1 plus C2 y2. So y1 will be cos x and y2 will be sin x. Y1 dash will be derivative of cos x will be minus sin x and y2 dash will be cos x. You have to find the Wronskian, that is the common term. Y1 y2 dash minus y2 y1 dash cos square x plus sin square x will be 1. You can proceed for finding u. Find out u. Minus y2 into capital X dx upon common term. What is y2? Y2 is sin x. Capital X is the function present on the right hand side. Common term is 1. Sin upon cos. Sec is cos. Sec is 1 by cos. So sin upon cos is tan. So minus tan square x. Tan square theta is sec square theta minus 1 and outside we have minus sign. So it will become 1 minus sec square x. So u equal to integration of 1 will be x, integration of sec square x will be tan x. You have got the value of u. After getting the value of u, you can proceed for v. Y1 into capital X dx upon common term. Y1 is cos x, capital X is sec x tan x. Cos and sec gets cancelled. Integration of tan x is log sec x. So you have got the value of u and v. Now pi. Pi is uy1 plus vy2. U is x minus tan x. Y1 is cos x. V log sec x. Y2 is sin x. So this is the pi. So after getting the pi, you can write the complete solution. Cs equal to Cf plus pi. So take the screenshot, please. I'll be winding up the session now. I'm having one more session in some other batch. Requesting all of you to hit the like button. Requesting all of you to share the link to your friends. Requesting all of you to rewatch it once. If you have any doubts, please let me know in the comment section. Thanks a lot. Bye bye. Take care. Tomorrow 9 a.m. we have a session regarding complex variables leftover portion. The first class for complex variable was conducted on this recent Sunday, which is past, and in tomorrow on tomorrow we'll be having class regarding complex variables. Thanks a lot. Bye bye. Take care.